Hello, everyone. Welcome to today's webinar from OGRA on the topic of mechanically stabilized earth wall systems, specifically introducing the Flex MSE Vegetated Wall System. My name is Amin Minena. I'm the Member Services Coordinator at OGRA and MEA. I will be your moderator and the host for today's session. Flex MSE is a product listed and approved in the Road Authority portal. I see that most of the audience is municipal folks, so if you're not familiar, the Road Authority is basically a big repository of public works products and services, and it's used by municipalities to manage, publish, and review their approved products list. Our current municipal members of the Road Authority include the region of Halton, Durham region, City of Hamilton, MTO, and latest member is the City of Toronto. So before we start today's webinar, a few housekeeping items. The webinar is intended to be a two-channel communication. So if you have any question during the webinar at any point, please submit your question on the Q&A function, not the chat function, the Q&A function that you can see in your Zoom control. If you would like or more comfortable asking your question verbally, you can raise your hand by clicking the raise your hand button, and when appropriate, I will give you the mic to communicate with the speakers yourself. This webinar is being recorded and will be made available on our YouTube channel. Now, as I introduce the speakers, I would like to engage the audience in a quick poll to gauge your level of understanding of the topic. So today we have Mike Collowert, the CEO and President of Trexiana, the manufacturer of Flex MSE. He is a geomodular construction specialist who helps engineers, designers, construction experts to tackle their traditional wall system or earth wall systems with a more sustainable, permanent, and cost-effective approach. We are also joined by Joel Kennedy, who has been in the civil construction sector for over 10 years. He has extensive knowledge of erosion and sediment control, water management, containment, roads, and stabilization, as well as MSE structure. Joel is the product specialist for Flex MSE. Joel's background is from Ontario, so he is well familiar with the specific needs, environmental and climatic needs of the Ontario region. Please join me in welcoming today's speakers. Mike, the floor is all yours. And
great.
Here's the results
Thank
for the
you.
poll.
Yeah, thank you so much. And I appreciate everyone taking the time today to sit in on the presentation. We have a bit to cover, so I'm going to dive in really quickly here. But I wanted to mention that the presentation is meant to be a conversation. So if you have questions, if I'm not explaining something clearly enough, or you have a second question, by all means, interrupt me. I love to talk about this stuff, and we'll leave time at the end of the presentation to discuss the details and any questions that weren't answered. So I want to talk a little bit right up front about mechanically stabilized earth, or MSE wall. You'll hear that phrase MSE wall, and it covers a lot of ground, really. It can be anything from straw and adobe blocks all the way up to engineered systems like you'll see today. So pretty typically when folks think of MSE, they'll think of things like a wire mesh or shotcrete or concrete facing, even things like wood crib walls or segmental block walls, that sort of thing. Even poured in place can be classified as MSE. With these types of walls, some of the challenges that we see with these is where if you might have differential settlement, overturning, you might see hydrostatic pressure or soil movement from behind the face. It can cause some pretty catastrophic failures. It can also just cause some, disruptions where you get a little bit of settlement and all of a sudden the system is no longer stable. So with Flex MSE, we're going to talk a little bit about how we fit into that category and some of the advantages. Flex MSE is a vegetated wall system. You'll see the second category here, this geomodular block and interlocking plate system. This is really a category that we've worked out with various governments and specifiers to come up with a category for Flex MSE, because we don't really fit with your typical categories. So if you see geomodular blocks show up on a plan or on a tender, they're talking about Flex MSE. The system's comprised of two main components. So our geotextile bag and our interlocking plate. Now you might be looking at this thinking, what's the big deal? It's a sandbag and a clip. It's actually closer to concrete than it is to a sandbag. So I want to talk a little bit about how it's similar to concrete, and then we'll talk about how we're unique to all other systems in the market. So like concrete, you stack in an offsetting pattern, so you create a running bond up your wall. The interlocking plate bridges the joint between two bags, so that when your subsequent row comes in, it centers over the plate, locks it into place, creating a mechanical connection. So you have hundreds or thousands of these throughout a wall. So there's no single point of failure, but they connect it together much in the same way that mortar or pinning might with other systems. If you want to make a Flex MSE wall green, you vegetate it. And so there's a number of ways to vegetate the system: grasses, flowers, trees. We get into that as we go. If you want to make a concrete wall green, you paint it. Then you come back in 2 weeks and you paint it again. For your folks that are designing and building in public space, maybe graffiti is an issue. Maybe that's a line item in your budget that you'd like to get rid of, so you can get that piece of equipment or that new hire. With Flex MSE, if they want to graffiti our system, we'll just hedge clip it off and call it a day. So that's really where the similarities end between the two. So let's talk about how Flex MSE is unique to all other systems in the market. So it can be installed anywhere from horizontal, so for channel claddings and outfalls, that sort of thing, all the way up to pure vertical, where it's attached to an existing structure like a living wall. We typically see 1-to-1, so 45 degrees, to 1-to-10, 85 degrees. The nice thing is it's the same two components regardless of your batter. So you're never getting that panic call from the job site saying, oh, the grading's changed, now we need a plate B with a bag C. It's always the same two components, so very versatile in installation. It's able to withstand almost unlimited differential settlement. So over a 10-meter stretch, the system can settle up to 2 meters without failing. So if you have 2 meters of site settlement, you have other issues, but a failed wall isn't going to be one of them. The way we were able to determine this is through FLAC analysis. So we were being considered for a diking upgrade in a very seismic heavy area. And so they, FLAC is earthquake analysis. So they modeled 10-meter sections of Flex MSE, a block, a basket, of earthen berm. And then they ran simulations from a 4.0 all the way up to a 9.0 with liquefaction. And the only system that survived that entire range was Flex MSE. The maximum settlement was 2 meters. So this is great for seismic zones, but it's also really great for areas where you might have less than ideal soil. So marshes, bogs, soft areas. If you saw a little bit of settlement, say you saw 150 mil or so, and you were satisfied that it had stabilized, it's very easy to add bags to the top of wall, revegetate it, and move on. With a hard armor system, if you saw that much settlement, you're likely taking the whole thing apart and resetting it and starting over. So really great for those challenging soil sites. The system carries a design life of 120 years, so this is a permanent application. The one caveat to this is that it's vegetated within 1,000 hours of peak UV. So what does that mean? In a desert, that's about a year of exposure. In Ontario, that's maybe 5 years of exposure. Our specification calls for the system to be vegetated within 6 months. So we want these things vegetated shortly after installation. We want folks thinking about that vegetation piece up front and making sure you have a beautiful wall at the end. System carries a 75-year warranty, which is pretty unheard of in the wall-facing industry. Typically, folks are designing to a 75-year design life. We'll actually warranty that entire period, and it's underwritten by the largest insurance company in the world. This qualifies for up to 21 LEED credits in 4 categories. So even if you're not chasing a certification for LEED, if you're on a LEED site or you're trying to build to a LEED standard, 21 credits is pretty incredible. Difference between gold and platinum LEED is around 20 credits. So, and these are things that are, you know, you don't have to squint at: recycled content, regional materials, low water landscaping, things like that. So very good for those types of projects. The system uses 97% less greenhouse gas than concrete and 98.5% less than steel. So if you're trying to reduce the carbon footprint or get to carbon neutral or reduce greenhouse gas, Flex MSE should be part of that conversation. We use 50% recycled content, and we're 100% recyclable. So folks have started using this for temporary works, even temporary weirs or dams, or even preload on a site. So if you're preloading a site for a building or a bridge, and instead of using concrete, you can use Flex MSE, you can vegetate it, and at the end of the load cycle, you can simply empty the bags, reuse that material elsewhere on site, and then recycle the bag and plate 100%. So it's a closed loop. The system installs in 2/3 the time of a typical wall. We can get that down to about half the time by your second wall. So we know time is money, and money's money. We come in at roughly 60% the cost of other systems. So when you're looking at something this versatile and this green, you expect to pay a bit of a premium. We actually go the other way, where we're nearly half the cost. The system can really help with a lot of your projects to keep you on budget, on time, and hit those environmental targets. So let's talk a little bit about where you can use Flex MSE. So for infrastructure, as we mentioned, we have our TRA Green A. We've had that for a number of years. For this example here, this is a road widening project, where you'll note as they're widening the road here, there's no traffic control or flagging needed. We're not using big machinery or specialized equipment. As they're constructing, they're still sitting in the services behind the face as normal. So there's a conduit for the lamp standard, and that can all go in as normal. At the beginning of this project, there was an environmental monitor who took clippings of the native grasses and flowers, and that was simply hydroseeded on the face at the end of the build, and you're back to nature. So very easy to naturalize these sites after the build and get it back looking good. This example here was the on-off ramps for a major bridge where they were building essentially on a bog. And so very soft site. Face weight was a big deal. We're about half the weight of the next nearest option. This is also facing onto the entryway to a golf course. So those folks didn't want to have that heat island and that potential coming off of that face. So they were really happy about the vegetated solution. It looks great and provides great coverage for some of that heavy traffic. This example here, this is the access to a quarry where they were building over a marsh. So you can see under construction, over winter here, and then construction complete. There's around 100 of these dump trucks that come in and out of this quarry each day. So it sees a lot of traffic. And this last photo here, this is 10 years post-construction. So you can see that ecosystem is continuing to evolve in what's an industrial site. Great result there. This last example in infrastructure, this is a 10.5 meter tall 4-lane roadway built on the system. This is a very challenging site. They've got old growth forest here. They've got a fish-bearing stream, and they have about 1.5 meters of laydown on either side of this roadway. So tight, in fact, the fellow that's hydroseeding here is hanging off a crane because it couldn't get equipment down that could lift them up high enough. This was originally specified to be a concrete block face. So in order to go up 10 meters, they would have had to go down 2 meters to lock in the toe. With Flex MSE, the maximum embedment we see is 300 millimeters. So you trench down 300 millimeters, 150 millimeters of clear crush, and then your first row of Flex MSE and you're back at grade. So very limited site disturbance. We're not hauling a lot of stuff away. We're not bringing foreign materials in. And then the finished product looks like it's been there all along. So a great result. This was just a natural wildflower mix and did a great job. So another area we do a ton of work in is anywhere land meets water. So fisheries and waterways folks love Flex MSE for three primary reasons. One is it doesn't create a heat island, so it's not heating that water up. Second is it doesn't leach anything, so not from the bags themselves, but it also prevents silt and sediment from transitioning from the backfill material. And the number one pollutant for waterways in the world today are silt and sediment. So what happens is they get into the water, settle to the bottom, create what's called an acoxic environment, so choke the oxygen from the plants and the fish and that sort of thing, and then can effectively kill a waterway. So we prevent that. And then the third thing is we're able to restore the riparian zone very quickly. So in this example here, this culvert was coming out into this little creek, failing timber crib wall here, replaced with Flex MSE. This is freshly hydroseeded here. This bottom photo shows after a single growing season. So we're already back to nature and back to that shady area here. And then the last photo here kind of shows this area under a typical storm event. So it flows beyond 3 and 4 meters per second with lots of volume. So the system can withstand that. This is a project from about 10 years ago now. And you'll see there's river cobble and riprap along the toe of this wall. We've actually moved away from that method now with Flex MSE. Instead of bringing in stone and other things that could cause heat island or could be easily displaced by water, we've actually moved to wrapping the lower courses in Geogrid. So, well, Geogrid goes in, two lifts of Flex MSE, and then grid folds back into the backfill zone, completely capturing those rows. And you know, if the scourer wants to try to remove those lower courses, it has to take the entire structure with it. So it's very strong. The vegetation still grows through the apertures in the grid, so it completely disappears, but it's incredibly strong. In this example here, this is pretty typical flow for this little creek, but under a storm event, they might get within a couple bags of the top of the wall. If the normal high water mark was up near the top of this wall, we would wrap 2, skip 2, wrap 2 until we reach that high water mark, creating an incredibly strong reinforcement without having to add rock at the toe. This example here, another little creek example. These folks here had mudslides that would take out this little creek. They'd have to dredge it every year. They rebuilt the banks with Flex MSE. They've even got a nice little head wall here with a walking path above it. And this bottom photo is 2 years post-vegetation. So live
Mike,
planted with...
sorry to interrupt.
Yes,
we have a question regarding this this point before you move on. The question is, how does the system handle water seepage from the bank drainage?
Yeah, so a great question. And we covered this a little bit as it comes up, but the system is a free draining system. So it doesn't require supplemental drainage. So we don't have a chimney drain behind the face, or we don't require drain rock behind the face. We actually want the water seeping through, and that's kind of where we part ways with traditional wall systems, is that if you're designing with a hard armor system, you're trying to get the water as far away from that face as you can. And we actually encourage it. So it'll feed the root system, and it acts as a great stormwater management even, because it'll slow down the flows and that sort of thing enough so the existing drainage can keep up with it. So great question. Certainly something that is a big advantage for Flex MSE is that ability to be free draining and accept that groundwater. So.
Thank you for the clear answer. On the same point, since we're talking about the drainage and how does it work with this system, how does the bag material stand up to chemical de-icing and pollutants that run off from roadways?
Yeah, so that's another good question. The system, the bag material is stable pH levels from a 2 to a 13. So it can withstand up to hydrochloric acid and really harsh chemicals. So salinity, chemical de-icing, hydrocarbons coming off roadways, that sort of thing, won't impact the material. It's very stable. So we have a lot of marine applications. We have a lot of tailings ponds and things like that where you're dealing with some fairly severe chemicals. So de-icing in the winter in Ontario for sure is a big thing, and the system can withstand that. So thank you for the question. So just to finish this thought here, so this bottom photo here with the ferns, they were live planted right into the tops of the bags, and this is 2 years post vegetation. So, you know, I like to say, you know, the good thing about Flex MSE is in a short period of time it disappears. The bad thing is in a short period of time it disappears. So if you want to show off your work, get folks out early, take lots of photos because it'll be gone before you know it. Couple other spots in waterways here. This is a major river system where you know, they had heavy erosion happening. This is First Nations land, so they were losing some of the mitten, and it's a heritage site, so they were really quite concerned. They weren't even allowed to drill pilot holes for earth anchoring here because of it's a heritage site. So we were able to build a launch apron here, and then a single face of Flex MSE at the shoreline. And the last photo here kind of shows the second 100-year flood we've had in the last 10 years in this spot. Lots of debris, flows that can get beyond 6 and 7 meters per second. This was meant to be a temporary fix, but this is 2004, and this is what it looks like currently. So, you know, those major systems, waterways, we can definitely use those. Another area we do a ton of work in is, of course, erosion control, that sort of thing. I want to show a couple examples of this. This is a municipal project where they had a shallow slope failure here from a water event. 4 guys from the municipality were able to show up. They filled the bags using the slough material that was on site because it's not structural. All they were trying to do is protect this compacted road base from further erosion. So they just stacked it up in a gravity-style wall, hydroseeded it the next day, and then they're back to nature. So very easy. I think they were in and out of the project in 4 hours without having to wait for anything to set up. No major machinery. It's quite a good project. And then this example here, this is in New Zealand where they had not a lot of room to excavate to kind of move this bank away from the roadway here, and they were getting a lot of erosion, and it would close off this little roadway. You can kind of see the fresh paving here. It had actually taken out this section. So they reestablished the bank here and then vegetated it, and now have stabilized this slope. So a lot of these really tough areas, tough to get into, tough to get reinforcement, that sort of thing. Flex MSE can fit into those areas and do quite a good job. So another area, of course, that we do a lot of work in is our slopes and walls. So this is a shot of our tallest slope to date at right around 21 meters. This guy in the center here is actually in the middle of the shot on the left. This is a really challenging site, roadway above, water below. Everything was staged off-site and then barged into the toe of the wall. And they constructed up 2 meters in 2 meters until they reached the top of a wall and drove off. To drive a single pile here was over $1 million, and we were able to complete the entire project for under $1 million. So pretty incredible. And then they hydroseeded it, and they're good to go. Commercial applications. So this little pathway here would have to be shut down twice a year due to flooding. Since they've installed the system, they haven't had to shut it down because, like I just said, the system is using that water to feed the root system, but it's also slowing it down enough so existing drainage can keep up with it. So it's great management there. This is 26,000 square feet at the face. 8 guys built this in 12 days. So pretty incredible production. 2 4-man crew completing between 1,000 and 1,200 square feet of wall each day, including grid, backfill, compaction, the whole bit. And now above this wall is a parking lot. There's a lot of commercial structures, gas station, a Walmart, that sort of thing. And the wall looks amazing, is providing a very serious site retaining function. This example here, this is in the city of Fredericton. So they had this area, this would flood every year, cause major issues. So they grubbed this all out of there and basically tiered this up, and were very creative in their planting. This is a 10 out of 10. These guys did a great job on this site. There's a heritage marker up top here, so they were concerned that the erosion was going to take the bank down at some point and topple the marker and all that sort of thing. So this area still floods. You know, they haven't quite figured that piece out yet, but it floods. But when the floodwaters recede, the wall is in place and still looking beautiful. So great job there. Things like trail systems, that sort of thing. This is supporting a roadway, but it's also bordering on a major trail system. You can see this is around 8 kilometers that cuts through a forest that they built with the system. Pretty incredible. It looks great, it looks natural, and this was a cut fill type of approach. And then the last wall I want to show you guys is this is our tallest pure MSE wall to date at just right around 13 meters tall. This is in Kirkland, Washington. Really tough to get a single shot of this from the ground, so we have a little bit of drone footage. This is the building site for a 3-story, 147 resident memory care home in Kirkland. Very challenging site. The engineer could not make block or basket work here because they had an enormous stormwater chamber buried in the backfill zone here. So they're trying to get to 20-meter runs of grid, and they could only get to about between 10 and 15. So one of the key things with Flex MSE is we follow the same conventions as block and basket. So if you have a plan sitting on your desk today that has a concrete face or a wire basket face, you can simply replace the face with Flex MSE and not have to redo your internal stability because we follow the same conventions of 60 to 80% of your overall height embedded every 600 mils of lift. The nice thing about Flex MSE being modular, though, is instead of every 4th row of bags, the engineer in this situation was able to put in grid every 2nd row or every 3rd row and increase the number of intervals going back without having to increase the length, and was able to get the strength profile he needed. The building is fully constructed now. It's within 1.5 meters of the front edge of this wall, and I could show you guys some photos of it coming up. But there were 2 major things that happened during the construction of this building after the wall was built. They had a 3.4 magnitude earthquake, and they set 3 rainfall records. This wall face was continually surveyed throughout the build, and they come in weekly and hit the sensors and that sort of thing, and there was 0 movement recorded throughout the build. So pretty incredible static loading there. So.
There's another question, Mike, if
Yes,
you would like to answer before we go forward. And Joel is also welcome if you want to jump in. Can Flex MSE be used in a wall that abuts a concrete wall? And if so, what type of connection is best between the 2 walls?
Sorry, so you cut out there on the first part of the question again?
So it says, can Flex MSE be used in a wall that abuts a concrete wall? If so, what would the connection between the 2 wall types look like?
Great, great question. We have a lot of hybrid walls, not just with concrete, but with stacked rock and that sort of thing, where you may start with one material and then finish off with another. Typically, a Flex MSE will just sit butt up against those materials, or sit on top of those materials if you wanted to use rock or something as your base, your foundation. So it'll just sit and it'll fit into the shape of the rock, that sort of thing. With concrete, we're going to connect to the grid. So say you had a concrete wall and then you decided to transition into Flex MSE, you would just continue your grid runs and whatever reinforcement you were using, and Flex MSE would connect in the same way that you would with your block wall. So there's a number of ways to kind of fit it together, and I can show you examples of where we've done that in municipalities where they've blended the segmental concrete block or they've blended the rock, and it works out really well. Great. Another question there, or we're good to go?
No, I was just going to comment on the person who asked the question. If you want more information or details, you can reach out to Mike or Joel independently after the webinar.
Yeah, absolutely. Yeah, anytime for our team. So moving on from walls, I want to move into landscaping, which seems like a pretty obvious one for us, but you know, there's a bunch of advantages to this. You can snap a straight line and create right angle corners, that sort of thing with Flex MSE, but you can also create an organic line or follow a line that's there, go over things like rocks and stumps and that sort of thing without impacting the integrity of the system. So in this case here, these folks, there used to be a concrete wall here, lots of graffiti, people breaking bottles against it. They'd hop over and party in this guy's yard. So when it came time to replace it, they had Department of Fisheries and Oceans, 2 First Nations groups, a regional district, a parks division, a community group, a lot of decision makers. And the only mandate was unanimous approval. So easy, right? This was the only system that kind of met everyone's needs. And at the end of the day, in this little park here, you've got this beautiful naturalized wall that looks like it's been there all along. They told us we couldn't put green walls in the desert. Well, this is a desert application at a winery where there's a vineyard above this wall that continued down to a road below. They made a 5-meter cut here to put in a parking lot, but there's a high plastic clay backfill. It's south-facing, you know, all those great things you want with a green wall in the desert. I have a lot of photos of this wall fully grown in, looking amazing. But I like this one because you can still see that drip line irrigation kind of poking through the grass. So I say build like concrete, finish like landscaping. So if your region requires it, your vegetation selection requires it, or your orientation of your wall requires it, then irrigate the wall. And you can do it with drip line, you can do it with spray heads, you can do it with light frequent manual watering until the plants are established, and then it can take on a life of its own. So like I said, this is kind of where we part ways with traditional systems where we want the water there. High-end residential, that sort of thing. I mean, these guys had a very steep lot with a little tiny house at the top. They raised that, pulled their building footprint out about 3/4 of the lot. They've got their cars parked at the top. They've got some pretty massive cedars to hold up. This was originally specified as a segmental concrete block wall. They went with Flex MSE instead, and they're getting all that engineered benefit, but aesthetically it's amazing. So good options there. We talked a little bit about at the beginning about LEED and green building. So these LEED credits here are available on our website. You don't have to try to read these right now, but it's obvious stuff like recycled content, regional materials, innovation in design, that sort of thing. This is the first gold LEED certified building in Canada. This is EA Games, the video game guys. This is their headquarters. This wall here is 200 meters long, and the batter on this wall changes 6 times over the course of the wall. So even though the toe is snapped to a line, they've got a soccer pitch and a tennis court and a basketball court and a park above this. So the top of the wall can accommodate those changes without impacting the integrity. This wall was live staked with willows. So the process here is you have somebody with a little piece of rebar and a mallet creating a void between the bags, and then somebody following behind filling those voids with willow cuttings, and then you splash a little water on it, and 45 days later, this is what you've got. This was in 2006, so these willows are now 20 feet tall. The nice thing about a willow is that it has a rhizomatous root pattern, much like grasses. So it's actually adding strength to the face because it's further connecting the face to the backfill zone and providing that further connection. So willow, alder, dogwood, all acceptable forms of vegetation for Flex MSE. So you're not stuck with just grasses or low-growing varieties. Next, I want to talk a little bit about public spaces and community projects. So this is a kilometer-long sound barrier wall in Red Deer that we did. This used to be farmland over here, and they decided to punch in the ring road around the city here. So the residents at this little subdivision weren't too happy about that. So what they did is they put in this 2.5 meter tall, kilometer-long sound barrier to separate the two. Now, if you know anything about sound barriers and that sort of thing, what you're trying to do with sound barriers is get to what 1. So 1 is anechoic, no sound. The concrete fences and that sort of thing you see along roads, they're pretty typically 0.6, which means that 40% of the sound is being reflected back. So that's pretty standard. When we did our ISO testing, Flex MSE, a single layer without vegetation is a 0.8, so pretty good. That's the equivalent of 4 sheets of drywall stuck together. A single row of Flex MSE with vegetation is a 1, so it's as good as it gets. So you can imagine in this case, they've got a row of Flex MSE, they've got compacted earth, they've got another row of Flex MSE, vegetated, nobody's hearing anything. The nice thing about the system, these guys had the room to build a wider berm. But the nice thing is that you can connect both sides of Flex MSE with Geogrid. So instead of a typical pyramid style berm, you can actually tighten up that base because you're connecting the grid to both sides. And so you don't have a big footprint, but you can still get the height that you're after. So great example of using the system there. We do a ton of trail work. So whether you're doing a cut fill trail, punching a new trail through an area, or you're doing a repair like these folks here, where they had a shallow slope failure, took out part of the trail here, we're able to reestablish the trail, implement their fencing, and then vegetate it with a native variety so that it completely disappears. So it's a pretty incredible. The system is really easy to transport into these sites. So in this case, these folks were staging it in a parking lot down the trail, and then they were using his track machine to get it in. But you could fill it right at site. You know, you bring in your materials. We have folks that'll just throw this on the back of a ATV and take it down a trail to fix a problem. Lots of options as far as that goes. For parks and golf course infrastructure, that sort of thing, we do a lot of that work. I really like this project as an example. This is at a golf course. They have this cart path here, and they had some pretty heavy erosion that was putting that in jeopardy. Had they come in here and fixed this using a hard armor system, they would have created a flat surface, which potentially could have sped the water up, would have changed the direction of the water, so caused issues further downstream. So with the system, they were able to come in and they just basically recreated the shoreline that was there before, planted it with the native varieties, and then they get back to nature, but they haven't impacted the direction of the water or heated it up or any of that sort of thing. So it's a really great way to kind of fix these issues. And then things like transitions between parking and facilities. You know, this is another golf course example where this path needed to be engineered because of the amount of traffic and equipment that goes on it. But rather than use concrete here to interface with the parking lot, they use Flex MSE, and then they match the planting that was on the facility site. So you're already transitioning into the beauty of the site. And now this is shortly after they planted. I have updated photos of this where it's fully grown in. It looks amazing, but it's an engineered wall. So this gives you a rough idea of some of the projects that we work on. We have roughly 7,500 projects worldwide, and quite often after one of these presentations, I'll get somebody will reach out with, oh, I got a weird one for you, and it's a napkin sketch of something they're trying to solve. And we can typically we can send you back an example of where we've done that before, or the type of approach to that solution. So I would invite you guys to reach out if you're thinking about Flex MSE for any of that stuff. I wanted to talk a little bit about filling and construction so you guys can understand what goes into this. You can fill these with a pile of dirt and a shovel, no problem. We also have plans on our website for these filling jigs, which will allow you to fill 18 units at a time using a yard bucket. So a 3-person crew can fill around 600 a day using this method. If you need 1,200 a day, you build 2 more jigs, you add 2 more people. It's very easy to scale. There's lots of machines in the sandbag industry. So this guy here will fill around 3,000 a day. It's automated, it's hopper fed, and so you can pick your method. We also have a great fill lot partner in Ontario who can deliver anywhere in the province. So these units can show up pre-filled to your site, ready to go in the ground, no problem. So if you don't have the time or the laydown or the labor or the materials, pre-filled is a great option for you guys. For construction, we're the only, sorry, was there a question?
Yes, actually our attendees are asking questions at the exact right time. Since you're talking about the filling of the bags, there's a question asking about what type of fill material goes into the bag.
Okay, yeah, great question. It's a 66% sand, 34% compost with less than 8% fines overall. So good clean sand, a nice compost, and blended by volumes. It can be mixed on site, it can be pre-screened, that sort of thing. The nice thing for municipalities in particular is that you guys likely have these two components already on site for other purposes. You probably have a good sand, you probably have a good compost. So for instance, the city of Fredericton, when they did their job, they used their summer students and their entry-level folks to fill bags over the course of a couple months in preparation for that project. And they probably saved themselves in the neighborhood of around $100,000 doing that because it was very gradual and inexpensive for them because they already had those materials at volume. So for municipalities, it's if you have the folks to do it, then I would suggest filling them yourselves and like 66, 34, and you're good to go.
Joel, you have something to add on this question?
Yeah, I was just going to say, should you not have those fill materials, again, these bags are available to be pre-filled at one of our designated fill lots in the region, and then we can ship them to site already pre-filled with the correct mixture that you don't have to worry about. So that's something to keep in mind as well. So if that is a concern, there is that solution as well.
Yeah. And another thing I'll add to that is if you're designing, if it's going out, if you're subcontracting this portion of the work out to other contractors, you may want to even just add a line that says must come pre-filled so you know what's in the bag, because we have the sieve analysis and nutrient analysis for every pre-filled unit that leaves our partners. So thank you for the question. I appreciate it.
All right.
As far as
we
had another one? Yeah.
No, just since we stopped anyways, I thought it would let you know that of how you're doing time-wise. We have about a little bit more than 15 minutes.
Perfect.
Of time. All right.
Great. Yeah. So talking a little bit about construction, we're the only vegetated system in the world that certifies its installers. So our certification is free. It's online. And we would encourage you and your team to take that certification for a number of reasons. Even if you're not going to be installing Flex MSE, if you're just going to be overseeing it, that knowledge is really going to help with that quality assurance, that sort of thing. I always joke that, you know, if you've built a wall before, you're overqualified for the system. We see a lot of professional wall builders really screw this up because they try to overthink it and that sort of thing. Having certified installers accomplishes two major things for us. One is you have a beautifully built wall. The second is you'll have these projects bid in reality. So if somebody doesn't know the system, they might, you know, double it and add 10 because of the unknown. If they've gone through certification, they understand what goes into it, they realize how easy it is, and they can go from there. Just quickly, you know, you just need a relatively flat base. First row of plates goes down. First row of bags center over those plates, and then you bridge the joint between each bag with another plate, offset by half a bag, center over the plate, rinse and repeat. It's really that simple and very easy to overthink. So I would encourage you guys to reach out and get that certification. Like I say, it's free, it's online, and you're good to go. For vegetation, the most popular method is still hydroseed. So if you're hydroseeding a Flex MSE wall, rather than use the straw or paper mulch you would typically use on your horizontal surfaces, we recommend using a flexible growth medium or bonded fiber matrix. There's lots of great products out there. FlexTerra is one that's quite used quite a bit on our system. The nice thing about FlexTerra is it goes on in 2 applications, and they guarantee adhesion for up to 18 months. So it gives the vegetation time to establish and germinate and that sort of thing. You can also make up to 3 inverted T-cuts in the face of each bag. to accommodate larger plugs, or 20 diver punctures to take things like fine plugs. We'll allow 20% of the face to be cut for vegetation. So you're not just limited to grasses and that sort of thing. You can be really creative with your vegetation. If you're installing near water or you don't want to cut the bags open, you can also use brush layering, where you're setting your root wad in behind the wall and bringing the plant out between the bags. Then you can have mature vegetation day one. This bottom photo here, this shows a bag that was cut off the top of a wall after 30 days. You see some grass and clover growth here. But what's important is the roots had already gone through the bag into the backfill zone and into the bags around it. And it's that deep root web penetration that gives you cyclical growth. So once the vegetation is established, you're not out there every couple of years revegetating or having to fertilize and that sort of thing. It takes on a life of its own. So a very nice closed loop system. All of the maintenance to do with the system is, other than periodic inspection for settlement, all of the maintenance is to do with your vegetation. So if you have a low tolerance for maintenance, you can be like these folks here, where this is an engineered wall that they didn't want to see rock or block here, but they also didn't want to have to maintain this. So they chose a dwarf fescue, which only grows a few inches and gives a good broad blade, good coverage, looks great for their applications. If maintenance isn't an issue, you can be like these folks here. There's around $50,000 worth of roses in this wall. Full-time gardener, beautiful wall. This project was actually quite interesting because there's a road that kind of goes up on an angle in behind here. There's a mountain stream that comes down one side. On the original master plan, this was just an odd pie wedge piece of property that was intended for a fountain and a sign and some landscaping. We were able to bench the site out enough that it gave them a platform for their show home. This just recently sold. I think the listing's still active, but the developer made out okay on this one. So you can imagine, from a piece of property that wasn't part of the development plan, to go to a $10 million, $9.6 million cash out is pretty dramatic. So, and then you get to avoid situations like this. So these shots, the top two shots here, are taken after the same period of rain. So you see that efflorescence, that calcification happening. Flex MSE just took all of that moisture and exploded in vegetation. So you might need to mow this lawn here, but I'll take that maintenance over this maintenance any day. Somebody's up here pressure washing this, keeping it looking good every couple of months. And then there are a few wire mesh or vegetated gabion systems in the market. Kind of the industry joke on those is they last as long as your vegetation warranty. So, after 2 years, you flip your calendar over and you suddenly get this die-off. The reason for that is that they're still primarily a rock-based system with a little sleeve of soil in the face that's meant to promote the vegetation. But if you ever looked at your garden beds or your flower beds after the rainy season or winter, they shrink. And so what's likely happened in this case is that all of that soil was consolidated down the bottom of the channel, and there's really no way to recharge it. So they just have to wait for the moss to take over or whatever's above to lodge over and cover it, but not sure that was part of the plan. So that brings me to the end of the formal presentation. I want to, before we get into any questions that might happen, I again want to thank everybody, and I want to thank Ontario Good Roads Association for having us. This has been an exciting leading up to this. I was really looking forward to presenting to the group and introducing you guys to Flex MSE. So thanks again. And if you have any questions that are there, I'd love to hear them.
Thank you very much, Mike, for this presentation. I learned a great deal on mechanically stabilized earth systems, and specifically ones that are can be more sustainable compared to concrete. I don't see any questions from the audience, but as we wait, I have a question that was on my mind from a design perspective. When using all LRFD, load resistant factor design, is there any is there any safety factors specific for this system that are established? And
yeah, so and that's a great question. You know, what we'll do is with everybody that's interested and reaches out to Good Roads folks, we'll get you access to the back end of our website for our technical library. So if you visit our website, this is kind of what you'll see. There's a few interesting features here that I can explain if we have time. But once you log into the site, you'll be taken into an area called Docs and Technical Info. And in this library here, you'll find everything you're going to need from grid connection tests, our ISO testing, permeability, that sort of thing, but also our factor of safety information is here. So, whoops, maybe it's not there.
Hey, Mike,
I'll make sure it is.
Load that up. There's a quick question from James. He says, I missed the very start of the presentation. Can you mention where you have been approved for use? MTO? Question mark.
Right. So to answer that question quickly, so we've got our green A with the Road Authority, and we're working through our MTO approval. So we'll be on that list. I've actually got it sitting on my desk here. We've been working through it. We were really ready to submit pre-COVID. You know, that's going to be an excuse for everybody. Pre-COVID, we were totally ready. But we were moving very closely to making our submission with the team there. We've been used on a few of the MTO projects, but we're also approved in the Maritimes, across the prairies, British Columbia, Alberta. We've been on those lists for some time, and we've had our, like I say, our green A for some time as well. So hopefully that answers the question a little bit. Yeah. Sorry, I'm just going to. I'll go through this a little bit here as we're trying to. I'm just trying to load up that factors of safety document, but it's in here and it talks about the various factors of safety for the design approach. We also have things like our standard spec engineer language. So this is all the caveats you can just copy and paste into your design and add your plan numbers and you're good to go. The other thing you'll have access to in the back end of the site are our full CAD library, so in DWG as well as PDF. So if you're designing, you know, if you're trying to figure out, okay, how do I put a fence post in Flex MSE? Very easy. There's a design here for that you can incorporate right into your plan that talks about our approach there. So from a CAD perspective, we've got, you know, 35 different standard CADs, and we're adding to it as we find different applications and that sort of thing. Technical information here, you'll find our bag filling material spec, as well as the filling jig plans. They're in here. Installation guides, seed spec examples, training videos, as well as a maintenance brief that you can leave with your maintenance crew at the end of the build to talk about what you can and can't do with Flex MSE for maintenance. Other documents are things like our warranty and the longevity. When I talk about 120-year design life, all the testing that's gone into that is in there, as well as photo sets, you know, pretty straightforward, small case studies, that sort of thing here. So there's lots of really good information in our technical library on the back end. And like I say, if you're interested in gaining access to that, you send us an email or reach out to the Good Roads folks, and they're happy to forward that request along. The last thing, do I have a couple more minutes here?
Yes, you have 5 more minutes to go.
And there's two quick questions here, Mike.
Yep.
Yes, there's one question I believe you addressed when going through the website is about who should they contact for concerning specifications for including in tendering process. I believe that would be available in your website, and you would set them up with a login.
Yeah, and Joel is the product specialist for Eastern Canada, so he is a great contact. Joel at Trexiana.com. We'll reach him, and he can help you with some of those technical aspects as well, in addition to the library. And then the system is distributed in Ontario by Terrafix. So when it comes time to get pricing or procurement, those are the guys you want to reach out to, and they can give you pricing on the system. But ultimately, if you're in design mode, that's our focus. You know, I always kid, we don't sell anything. we're your technical support. When it comes time to buy, that's somebody else's thing. So I would encourage you guys to reach out if you have those technical questions. So
Thanks, Mike.
I wanted to show just quickly then, with my remaining time here, one of the tools, and this is right kind of outside of the envelope of the folders, but this estimation tool here is a great tool. So now you guys have just learned about Flex MSE, but you love it. It's going to be on every one of your projects. So now you have to figure out, okay, how am I going to go back to my client and figure this out? So if you go to our estimation sheet, you just need to enter some basic information. So let's say this wall here is 3 meters tall by 300 meters long. So just knowing the average height and length, you're already kind of on the way. The first question you're asked is, what type of wall are you going to build? So for us, anything up to 0.6 of a meter, gravity stack is typically fine. Anything up to 1.2, you can use what's called our tieback, which is where every second row, every second bag is turned perpendicular to the face. So like a dead man on a crib wall. Any wall that's going to be above 1.2 meters, or any wall with loading, you're going to have a geotechnical design, and you're going to use Geogrid in that. So for this wall, it's 3 meters. We'll select Geogrid. Next question is, do you require top cap? So top cap is where every bag at the very top row is turned perpendicular, so you can tie in with an existing grade. For this wall, we're going to say we're going to leave it as is. So now we know we need 11,700 Flex MSE units and 5,100 meters square of grid. Next question is, are you going to fill these yourself or buy them pre-filled? So for this exercise, we're going to fill these on site, fill these ourselves, and by selecting that, now we know we're going to need 390 cubic meters of bag fill material. It's going to take 585 man hours to fill them using our jigs, and 585 man hours to install them. So if you know your numbers, if you know what your man hour, your average man hour rate is, you could start to do the math on see if this makes sense from a budget perspective. And the reason we separate the two, the bag filling and the installation, is these are two different types of crews. You know, the first one is smaller crew, 3 people putting dirt in bags. The second one is a larger crew with machine operators and installers and that sort of thing. For bag filling, so if you had 585 hours divided by 3 people working 8-hour days, you would fill these 11,000 units in 24 days. So if you needed them in 12 days to build 2 more jigs, you add 2 more people. For installation, if you had 585 hours divided by a 4-person crew working 8-hour days, you would build that 900 meter square wall in 18 days. And there's around a 20% contingency built into these numbers. So you don't have to pad it for bad days. You can have a lot of bad days and still hit budget. But this can be printed off and put into your file and therefore, you know, for the records. So that's a really helpful tool. Again, that one is just outside of the folders here once you log in. A very helpful tool if you're considering Flex MSE. And so that, I just wanted to show you guys a bit of that for sure. Sorry, I'm still trying to get your factors of safety up here, Austin. But if you have questions, if anybody else has any other questions, I'm happy to hear.
I believe there's one question asking on the average cost or linear cost per linear meter of Flex MSE. Feel free to, if you would like to answer it privately, you can.
I mean, sure. Yeah, there's a lot of things that go into factoring the cost. So if you have to truck materials, if you have to, you know, there's all kinds of things that can impact it slightly. But we typically see in Ontario anywhere from 250 to 300 per meter square completed. So that's meter square. It's kind of how we judge it. So the same wall as in other materials can be in that 390 to 450 range. So we're typically 60% the cost of other systems. Again, it's an exercise. We're happy to step through with you to create, to come up with a good quote and a good budget number. So if you have those, feel free to reach out and we can, hey, you're in this region, this is where the materials have to come from, and start to work that out. But yeah, we typically, at 220 to 300 per meter square.
And that's installed price, just so everybody knows. So I don't
Yeah,
think
materials and install.
Yeah.
Yeah. Thanks for that, Joel. Let's see if we can get this factor to say, there you go. We did it.
Oh, awesome.
Yeah.
Okay. So that's very helpful and for designers and design engineers to have.
Absolutely.
Yeah. So you can download this as a PDF as well. And so yeah. Sorry, I didn't have that loaded up right away, but it's there now. So yeah. Right. Any other questions sitting there? I think we're right at time now. So.
Yes, I see no more questions. So if anyone has any other questions, feel free to reach out to me and or Mike or Joel. I will send out their contacts after the webinar to all the registered attendees. And at the end, thank you very much, Mike and Joel, for your presentation. It was very very interesting and very beneficial on topic and on point. And I would like to thank everyone who participated in today's webinar and joined us. You can find more information about Flex MSE on the Road Authority or website or Flex MSE website. Again, a copy of the recording of the presentation will be made available on YouTube and will be shared with all of you that registered for this webinar. Thank you very much. Great. And have a great day.
Take care.
Thank you, everyone.
Bye-bye.